Okay, let's do problem 135 candy. Instead of reading the question, let's have a look at the examples and see what they want us to do. So we are given ratings 1 or 2, and what we need to do initially is we have to give each child at least one candy. And if the neighboring, if the value of rating is greater than the neighboring, we have to give one more candy. So because 1 is greater than its neighboring, we have to give one more candy. And when we look at the 0, it's smaller than the neighbors. And then when we look at 2, it's greater than the neighbors, so we have to increment the candy by 1. So we do have 2, 1, 2 candies, so we return the sum of the candies, which will be 5 as expected. And likewise in the next one we give 1, 1, 1 candies, and then 1 is not greater than the neighbor, this 2 is greater than the neighbor, so we increment it by 2, and then this 2 is not greater than the neighbor, so we leave it like that. So we are returning 1 plus 2 plus 1, which is 4 candies. Is there any better way of doing this? Can we make it more systematic so that we can apply that to our code? Well, let's see. Let's have a look at a more complicated scenario. So we have 1, 3, 5, 4, 3, 2, 1 candies. Without any systematic approach, here is what we're going to do. This one is smaller than the neighbor, so we do nothing. Or initially we give 1 to all the candies, or 1 candies to all children. And when we look at this 3, it's greater than the neighbor, so increment by 2. And when we look at this 3, this 5, it's greater than the neighbor rating, so we it has to give 1 more candy to the neighbor, so it has to be 3 because we have to do plus 1. And then this 4, when we look at this 4, it's greater than the neighbor, so we give 2. And then when we look at this 3, it's greater than the neighbor, which is 2. And because this 4 is greater than the neighbor, we have to increment this by 1 as well, so it has to be 3. And then when we look at this 5, we have to increment by 1 as well, because it has to be greater. So we can repeat this over and over again, but we can't really apply that logic to our code. Is there any better way of doing this? Yes, instead of doing that, what we can do is we can traverse from the left to right and apply our logic. So if the rating is greater than the left neighbor, we increment the candy. And then we also do that again from the right to left, and then say if the rating is greater than the right neighbor, we also increment the candy. So what we are going to do is we're going to give 1, 1, 1 to all the children, and then we're going to do the from left to right. So it will be 1, and then it will be 2. This 5 will become 3. This 4 will remain 1. This 3 is also remain 1 because it's smaller than the one on the left. Also 2 will remain 1, and 1 will remain 1. And then using these values we have, we're going to traverse from right to left and compare if this is greater than the one on the right. Let's see. Yes, we have 1 here. It does not really change. And when we look at 2, yes, it is greater than 1 on the right, so it becomes 2. 3 will become 3. 4 will become 4. 5 will become 5. Because it has to be plus 1 to the one on the left. And then this 2, when we look at this 3, it's not greater than 1 on the left, so it remains unchanged. So that's how we apply our logic. But there's one more thing we have to watch out for. So suppose the if it was just 3, we only had up to 3. and our output will be like this. And then when we traverse from right to left, what we're gonna do is we actually have one more, so I'm gonna rub this out. So 3 will still have 1. 4 is greater than 4 is greater than 3, so it will become 2. This 5 is remain. Okay, let's do it this way. Makes more sense. And 1 will remain 1. And then 5 is greater than 4, so should we do +1? That was the logic we have, because if the neighbor element was smaller than the one we're looking at, we did whatever candy the neighbor has and then +1. But we don't do that because this 3 is greater than the result. So if this result is greater than the neighbor candy +1, we just use that number, so it becomes 1, 2, 3, 1. Great, so let's try to put that in our code. So we do need int candies equals new int. The size will be ratings.length. Size. Okay, and what else do we need? We actually need after obtaining all the candies, we have to add all of them up. So I'm gonna call that int sum equals 0. And right, so I guess that's enough. And what's important is we have to initialize the candies to 1. So we're gonna do int I equals 0, I plus, I is less than size I plus, and then candies the I is equal to 1. Okay, so that will be initializing candies to 1 for all the children. And then what we need to do is we have to update our candies while traversing from left to right. Again, the logic is the same. For int I equals 0, I is less than size, I plus, and we have to do some operation. But the thing is, the first element does not have the left neighbor, so we can actually iterate from I equals 1. And then we can simply say if ratings.I is greater than ratings.I minus 1, the one on the left, what are we going to do? We're going to say candies.I is equal to candies.I minus 1 plus 1. So we have to increment to whatever the neighbor enable child, whatever what am I saying? We have to increment the number of candies for the current element. The current number of candies should be whatever the previous the left neighbor has plus 1. And that's it for our left right, and then we have to update from right to left. Again, we are going to do int some sort of for loop. Again, we are going to start from the second one on the right, so it will be int I is equal to, usually if you want to start from the far right side, it will be size minus 1, but because it's second one on the right side, it will be size minus 2. I is greater than or equal to 0, and then I minus. And we do need to have a condition that if ratings.I is greater than ratings.I I plus 1 if it's greater than the one on the right. And then we do need to have some condition. If candies.I is less than or equal to candies.I plus 1. So we only update if candies is not greater than the one on the right. And what do? We do candies.I is equal to candies.I plus 1 plus 1. So that's our number of candies fully updated, and then we have to get the sum. So before int I equals 0, I is less than the size, and then I plus plus, and then we do sum is equal to sum plus candies.I, and then we have to return sum. Alright, so let's run the test. Okay, it's accepted. Let's submit. Okay, so that's it.